Let's take a problem on binomial theorem, okay, and expanding a particular given number. So you have basically expand a plus 4 upon a to the power 4, a is not equal to 0. Now we know in a binomial theorem, any number, let's say for example x plus y to the power n is equal to nc0, x to the power n, y to the power 0, right, plus nc1, x to the power n minus 1, y to the power 1, plus nc2, x to the power n minus 2, y to the power 2, plus ncn, x to the power 0, y to the power n. Right? Now applying this theorem to this particular case, what do we get? We have x is equal to a and y is equal to 4 upon a. Right? So this can be written as nc0. Now what is the value of nc0? The value of nc0 is basically 1 into x to the power n, a. And n is what? N is equal to 4 in this case. Y to the power 0 plus nc1. N is what? 4. So we get 4c1, or simply we know that ncr is equal to factorial n upon factorial r upon factorial n minus r. Right? So what do we get here? We get 4c1 here. 4c1. So this can be written as factorial 4 divided by factorial r, which is 1. 4 minus 1 factorial. Or 4 minus 1 can be simply written as factorial 3 into x. X is what? A to the power 4 minus 1. 3 y to the power 1 plus nc2, 4c2. So this will be factorial 4 upon factorial 2 into factorial 4 minus 2, right, into x, which is a, n minus 2, 4 minus 2, which is 2, y to the power 2 plus. Then we get nc3, which is 4c3, right, 4c3. So this will be factorial 4 upon factorial 3 into factorial 4 minus 3, or 1, into a to the power 4 minus 3, 4 minus 3, 1, into y to the power 3 plus. What do we get? The next one is 4c4, which is basically the last term now. Why? Because ncn is the last term. So we get factorial 4 upon factorial 4 into factorial 4 minus 4, 0, into a to the power 0, 1, we reduced it, y to the power 4. Right? So let's see the solution for this. The first term is very clear. A to the power 4, y to the power 0 into 1 is equal to a to the power 4 plus factorial 4 divided by factorial 3. Now we know factorial 4 is equal to what? 4 into factorial 3. So this factorial 3 will cancel this. We'll get 4 a cube y plus. Again, factorial 4 is equal to 4 into 3 into factorial 2. This factorial 2 will cancel with this factorial 2. Okay, 4 times 3 is 12. 12 divided by 2, because factorial 2 is 2, is 6. So you get 6a square y square plus factorial 4 divided by factorial 3. This we've already done, right? This is what we had here also. So this is 4a y cube plus factorial 4 divided by factorial 4 is 1. So you have y to the power 4. Now let's substitute the value of y in this particular equation, right? So we get a to the power 4 plus 4a cube into 4 upon a plus 6a square into 4 upon a whole square, which is a square 16, plus 4 into a into 4 upon a cube plus 4 upon a to the power 4. A to the power 4 plus this a will knock off one power from here. So 4 times 4 is 16 a square plus, again this a square will knock off this a square, 16 into 6 is 96 plus this will be basically a cube 4a into a 4 cube is 64 upon a cube, okay, plus 4 times 4 is 16 into 16, 256 upon a to the power 4. Or maybe we can just simplify it a little more. A plus 4, 16 a square plus 96 plus this will be 256. A will knock off one power from here, so you will be left with a square plus 256 upon a to the power 4, which is your answer, right?